In the last video, we looked at geometric properties of the parabola. In this video, we'll be applying those properties to solve a very interesting question. Now, I do recommend, if you're not familiar with geometric properties of the parabola, you look at my last video as I explained it over there. And today, I decided to rock the whiteboard because my handwriting was really trash on whiteboard, like on the actual Microsoft whiteboard. Basically, I just had really bad handwriting last video, so I'm going to attempt to make it neater on an actual whiteboard. So yeah, who cares? So the question states that I'll talk a little slower now. I just wanted to get that stuff out of the way. So now the question states that a segment through focus F of a parabola with vertex V is perpendicular to segment FV in points A and B. What is the cosine value of angle AVB? Now, as you can see, I sketched the equation, or the graph, or the parabola, y is equal to x squared. So I sketched it on a Cartesian plane with 2 dimensions, obviously the x-axis and the y-axis. And I basically what's happening in this question is that there's a focus named focus F, and there's a vertex named vertex V, and then there's a segment that runs through the focus and is perpendicular to FV. So basically AB is perpendicular to FV. And also note that we didn't cover this in my last video, I forgot to, but also note that AB is also known as the lattice rectum. So segment AB is also known as the lattice rectum. And don't worry about the value of the lattice rectum yet. As we do this question, in fact, the very first step is to calculate for the value of the lattice rectum. But if you have it memorized, good for you. But don't worry about the value for now. We're going to derive the value of the lattice rectum. It's just good to know that the lattice rectum is also known as AB. So anytime you have a chord that runs through the focus and is perpendicular to the focal length, it's known as the lattice rectum. And the focal length is the distance from the focus to the vertex, or from the directrix to the vertex. So that brings me up to a good point. In this case, we know that the directrix is not explicitly stated in this question, but we're still going to add it because it's very important to the geometric definition of a parabola. So let's add the directrix in another color. Let's just say this is the directrix, and we're going to call it line D. So line D for directrix. And so we know that if we call FV, let's classify the length of FV as P. So let's say FV is equal to P. Alright? So if we note that if we drop a perpendicular down, and we say this is point X, and we drop a perpendicular down and we say this is point C, we know that this is equal to 2P. We know that AX is equal to 2P, and BC is equal to 2P. By geometric definition of a parabola, right? Because all points are equidistant from the focus and the directrix. Therefore, this is P, P, and then P, P, and then P plus P is 2P. So we get that AX is equal to 2P and BC is equal to 2P. And so we can say that since AX and AF are equal due to the geometric definition, we can say that this is also equal to 2P, and this is also equal to 2P. And even though they don't look equal, it's just because I'm very bad at drawing. So don't worry, just note the geometric definition of the parabola states why this is true. And now you can say that the lattice rectum of a parabola is equal to the absolute value of 4P, because we're talking about distance or length, right? So yeah, I guess we derived the lattice rectum. So that doesn't even matter. So since we have this, we want to find... Okay, so we know that we have 2 right triangles. So what we have to do now is we have to find the distance from, or not, I should say length, the length from AV and the length of VB, right? Because we have 2 lengths, so we're going to use the Pythagoras theorem to find AV and VB, right? So the Pythagoras theorem states that C squared is equal to A squared plus B squared, right? So we note that if we want to find the length of VA, it's going to be equal to FA squared plus FV squared, which is equal to VA squared. So to find VA, we take the radical of both sides, and we say the square root of FA squared plus FV squared is equal to VA. So in this case, FA is 2p as we solve, but now we have to basically square that, so it's going to be 2p quantity squared, and then FV, by definition, we said that FV is p, or the focal length, so we have to square p, so p quantity squared, and it's equal to VA. So if you simplify this down, we get, it's the square root of 4p squared plus p squared, which is equal to p root 5, which is equal to the length of VA. Now, since we know that these triangles are obviously congruent, they're congruent by, what's it called? If you can see, they're congruent by side angle side, obviously. Well, they're congruent by side, because, yeah, they're by right triangle, since their two legs are congruent, we know that the triangles are congruent. So they're actually congruent, these two triangles are congruent by side, so we know that corresponding parts are equal in two congruent triangles, so we also know that VA is also equal to VB. So basically what I'm trying to say, since these two triangles are congruent, then we know that VA and VB are both equal to p root 5. So now we've calculated that. So now how do we actually now find the cosine value of p root 5 of angle AVB given all this information? So let me write this over here. This is p root 5. And then this is so how do we calculate the cosine angle of AVB? Or how do we calculate this angle? Well, remember the law of cosine states that c squared is equal to a squared plus b squared minus 2ab times cosine angle c. Now, I could prove this, but this video is not for the purpose of proving the law of cosine. So just take faith in this equation, okay? Or this formula, should I say. So, using this, we know that this is a law of cosines. So what we need to do is, in order to find angle AVB, we must use the segment. We must define the segment opposite of angle AVB as C. So the segment opposite of angle AVB is AB. So basically AB is going to be equal to C. And then we're going to use the rest of the segments. We're going to use VA as A. And then we're going to use VB as C. So if we plug this in, we get AB squared plus AB squared is equal to VA squared plus VB squared minus 2 times the product of VA and VB times cosine angle AVB, because it's an angle opposite of segment AB, right? So now we just have to plug in all the information we have. So AB squared is the same thing as FA plus FB squared, which is the same thing as 4P quantity squared. So it's going to be 4P parentheses quantity squared, and then it's going to be VA is equal to VA squared, which we said was P root 5, but now we have to square it, so P root 5 quantity squared, and then VA and VB are equal, so VA squared so since we know that VA and VB are both equal, then VA squared is equal to VB squared. So we know that this is also plus P root 5 quantity squared. Then, since we know that VA and VB are both P root 5, we can say minus 2 times P root 5 quantity squared, or 2 parentheses P root 5 squared, times cosine angle AVB. Now, we use simple algebra. We say 4P quantity squared is 16P squared. We get P root 5 squared is 5P squared. And then plus 5P squared minus 2 or minus 10P squared times cosine value angle AVB. And then we know that we're trying to isolate to solve for this. So we use algebra. We subtract 10P squared from both sides to get rid of this. And we get 6P squared is equal to negative 10P squared times the cosine value of angle AVB. And then we divide both sides by negative 10P squared, and we get negative 3/5 is equal to the cosine value of angle AVB. And there you have it. We've just used the Pythagoras theorem and the law of cosines to solve for a very interesting question. Stay tuned for the next video. And we're probably going to continue teaching about conics in the next video. So stay tuned.